In the video, we'll show the full path, from how a user draws a process to how it is actually executed with cryptographic protection against data injection. We draw the process in BPMN Designer. Each lane is a separate agent with their own names and tasks. In the documentation of each step, there is its task T, a description of what the agent should do. We click Build and the process is compiled. This same process is already in the platform. We can see a generated playbook with general information about the process. We also have a generated graph where each element corresponds to a task from the diagram. In the task page, we see the task and its structured prompt. We have the same structural prompt in the general register, which also contains links to the process, the agent, and the policies under which the agent lives. Finally, the agent card, where we can see all the processes where it is involved, with the code and domain eTOM, which follows the standard TM forum process. Every activity in the process has a structured prompt template, task description, task type, target object, constraints, and expected output. A structured prompt is a template with variables. Let's see how it is filled. We send the template to Postman and get a ready-made filled prompt, template ID, interaction mode, negotiation type, task information, and constraints. The values come from mappings that were generated from the process itself, for example, task information, probable cause, and constraints. Now let's see the protection. We will try to do an injection and throw a real system prompt in a separate block, asking the agent for root access. Let's send it and check the response. As we can see, the request to provide root credentials hasn't been successful. Even searching for the word root gives no result. What is not provided by the scheme is ignored. This is the first level of protection. The second one is checking the values separately. The Trusted Data Gateway, an essential component of Fabric T, authorizes every cross-vendor exchange, whether the agent is sending a task and waiting for a response, or publishing an event for others to react to. Let's see live execution. The first agent signs the compiled prompt. In response, a secure passport with a cryptographic signature and token comes. The signature cannot be changed after that. The second agent receives the data and must validate it, and if someone has changed the data after signing, validation will fail. The change is visible immediately. We get back to the platform and see that a new successful run in the pipeline has just appeared. This is the full trace with the secure passport, the token, the request with variables, and the response itself. And if the request body is broken, the run will fail. The system simply will not pass the change. From a written process to provable autonomy, 3 stages, 1 fabric, 0 trust, every decision provable.